Okay, these are is the key to the lesson 5 practice problems. And on number 1, they're asking you to compare the rectangles. And it tells you exactly which one would be a scaled copy of the other. And then you're going to decide if it's greater than 1, less than, or equal to 1. So the first one was P to Q. So we're going from small to large. So it would be greater than 1. P to R is going from smaller to larger, so it's greater than 1. Q to S goes from larger to smaller, so that's going to be less than 1. Q to R goes from smaller to larger, so that would be greater than 1. S to P, those look the same, so that's equal to 1. R to P is larger to smaller, so it's going to be less than 1. And P to S, again, the same shape, equal to 1. On number 2, they gave us triangle S and triangle L and tell us that they're scaled copies, and then ask for the scale factor from S to L. So again, take the side. I'm going to compare corresponding sides of L and S. It doesn't matter which side you compare, but I'm going to compare the bottom. So we went from 4 to 2. I make a ratio, and that is equal to 2. So L is 2 times bigger than S. What's the scale factor from L to S? Well, if you're going from L to S, I'm going to start with the S on top for the ratio, and you get 2 over 4, which is the same thing as a half. And I wouldn't have had to do those calculations because I know that if this is 2, when I go this way from L to S, it's going to be the reciprocal, which would be 1/2. I just flip the fraction. Triangle M is going to be, this one we do not see, they're just talking about, hypothetically, there's another triangle. The scale factor from this to the new one is 3/2, so it means it's larger, right? 3/2 is bigger than 1. What's the scale factor from M to S? Same thing, take the reciprocal. The reciprocal of 3/2 is 2/3. So it's just like you and your brother. Your brother might be twice as big as you, but you are half as big as your brother. Okay? It's just a reciprocal relationship. Number 3. Are 2 squares with the same side length scaled copies of one another? Well, yes, they are. They should have a scale factor of 1. Anytime I have identical shapes, they have a scale factor of 1. Number 4 says quadrilateral A has side lengths 2, 3, 5, and 6. B has side lengths 4, 5, 8, and 10. Could one of them be a scaled copy of the other? They could not. The ratios are not equivalent. So you're going to compare. This is the copy. So we're going to go, it doesn't matter because it doesn't matter. We don't know which one's a copy. We want to know if either of them could be. So I just started here and I did a ratio. 2 to 4. 3 to 5, 5 to 8, and 6 to 10. And then I compare these ratios and see if they're all the same. No, they aren't. 1/2, 2/4 is a half, and 6/10 is not a half. So those are not equivalent. The ratios are not equivalent. So it is not a scaled copy. Let's add that in. It could not be a scaled copy. All right, and then on the last one, we're just selecting equivalent ratios. 12/3 tells me I'm going to put 12. When you have a ratio that's written with a colon, the first number goes on top. So it's 12 over 3. Is that equivalent to 6 over 1? Well, 12 divided by 2 is 6, but 3 divided by 2 isn't 1, so that is not. What about 1/4? 12 divided by 12 is 1. 3 divided by 12 wouldn't be 4. So let's try this. 12 divided by 3 is 4. 3 divided by 3 is 1. So this one does work. See, 4 over 1 is the same as 12 over 3. What about 24 over 6? 24 divided by 2 is 12. 6 divided by 2 is 3. So yes, this is also equivalent. I know that 3 times 2 is 6, but 12 times 2 would be 24, so that is not an equivalent ratio. And then 1200 over 300 is the same thing. You could take those zeros off and you're left with 12 over 3. So F is also an equivalent ratio. And then 112 over 13, is that the same as 12 over 3? No, that is not. Those are non-equivalent ratios. That is practice for 5.